Hey, what's up, Morpheus? Welcome back to the commute. In this video, we're going to be exploring polymorphism. If you haven't watched my previous video where we have explored inheritance and encapsulation, the previous videos are available for you and you can watch them right now. For now, let's get started with polymorphism. Let's try to take a look at the official definition of polymorphism. An object can take many forms. So let's try to break it down. Let's first of all write it down here quickly. So what do you mean by an object can take many forms? Let's take an example of a vehicle. Now this particular vehicle can actually take many forms. Like it can be a type of a car, it can be a type of a bike, and it can be a type of a truck. So a vehicle object is taking many different forms, and that is exactly what polymorphism means, right? Breaking down polymorphism into simpler words, it would be poly and morph. Okay, what does poly mean? Poly means many and morph means form. Okay, many and form. So it means that an object can take many forms. Okay, let's look at an example of polymorphism and how actually we can achieve it. Okay, let's try to make a class here which will be a simple vehicle class, and let's try to achieve polymorphism on it. Here are simple 3 variables inside of vehicle, and we want to manipulate these with the help of some kind of functions maybe, or let's make simple functions to print something out. Okay, now this is a very simple open class called vehicle. Now if we want to achieve polymorphism, it means that we have to make some kind of a vehicle and we have to actually inherit its properties, right? That's how polymorphism actually works. What we do is make a simple class here called car, which is a type of vehicle, right? And then we inherit its properties, right? And now we can use these properties, and this particular vehicle object has taken a form of a car which is much different from just a vehicle. A vehicle can also be a type of bike, a vehicle can also be a type of a truck. So my vehicle is actually taking many different forms, and car can have its own specific properties which will be much different from what a bike might have. Okay, simple as that. Function we are overriding. Let's override the function tires, right? And we will say println cause have tires. Then we make a class bike inheriting from the vehicle, sports mode inside of the bike, and it's just gonna say sports mode in bike. Simple as that. Hopefully you can see that. Let's try to make it actually work. Okay, let's make a car class, right? Car dot sports mode on, and what we see is sports mode in car is on. Hopefully you can see it. We can say bike dot. Okay, first of all we have to make a bike object, right? Bike type of bike dot sports mode, and what we can see here, it's sports mode on in bike. You can see it, right? Sports mode is on in bike, sports mode is on in car. As you can see, what is actually happening here, the vehicle object itself is taking many different forms. That's what exactly polymorphism means. Now what we can do is, let's just say that this is our car. Like let's say our vehicle is some kind of vehicle, right? It's a type of vehicle, and now we want to initialize it. Let's just say it is a car. Now as you can see, car initialization of the class is actually taken by this vehicle variable of vehicle as a type of vehicle, right? And this car initialization is actually taken by it. Why is it happening? Because the vehicle is a type of car. The object has taken many different forms, and that's exactly what polymorphism is doing. Hope you understand this stuff. Now how can we achieve polymorphism? Now polymorphism can be achieved with the help of interfaces. It might be interfaces that we are using, or maybe abstract class. We can use that, right? We can just open a class and try to inherit its properties, and that's also polymorphism, and that's how everything is done. Now the polymorphism itself is of 2 types: compile time polymorphism and runtime polymorphism. Let's try to understand that with the help of this particular example. Runtime polymorphism simply means method overriding. Compile time polymorphism means method overloading. Why is it even known as compile time and runtime? Let's try to understand with this particular example. Okay, now this is called method overloading itself. We have 2 functions with the same name, but it will be decided on the runtime which particular function will be used and which particular function will give us the output. Now this is an example of method overloading, which means compile time polymorphism. The output of this function will be decided by itself in the compile time, whereas if we were to override something, we will only have the output when we actually run it. Okay, the overriding only happens in runtime, whereas at the compile time we can easily decide at which position we are overloading the function, right? If you were to say vehicle dot sports mode, the sports mode isn't available in the vehicle itself. We have to define the car here. The sports mode is available. Okay, the sports mode And then we can say, if we do not define any name in it, it will automatically just print sports mode in the car. If you were to define a name inside of it, a Mustang, it will print sports mode in Mustang. It means it is using the second function. This is method overloading, or simply compile time polymorphism. The tire function, which was available in the parent class of vehicle, has been overridden. Its functionality has been changed. Okay, so that's basically runtime polymorphism. If you were to say 4, tires equal to 4, and what will it print? Car has tires 4. Okay, I hope you understood the difference in the two polymorphisms. I hope it makes it much more clear now. And for now, this is it. Thank you for watching, and I'll catch you next time. Bye bye.